2 days ago, Google's Threat Intelligence Group published a report confirming that a criminal hacking group used AI to build a working zero-day exploit and were days away from deploying it in a mass exploitation campaign before Google stumbled across it. Google's Threat Intelligence Group is the team inside Google that spends its days tracking nation-state hackers and cybercrime gangs figure out what they're building before it lands. During one of those proactive investigations, they found a Python script being prepared by a prominent cybercrime group for what the report describes as a mass exploitation campaign. The script exploited a zero-day vulnerability in a popular open-source web-based system administration tool, the kind of tool IT teams use to manage servers remotely. And it did one specific thing. It bypassed two-factor authentication. A zero-day, for context, is a vulnerability that the software vendor doesn't know about yet, and therefore has 0 days to patch. Historically, they've been expensive and rare because finding one requires deep technical expertise and a lot of time manually auditing code. This one, according to GTIG, was found and weaponized by an AI. It was a semantic logic vulnerability, a hard-coded trust assumption in the two-factor authentication enforcement logic. And the AI found it by reasoning about developer intent rather than scanning for known patterns. GTIG's chief analyst John Hultquist said that kind of high-level logic flaw is exactly where LLMs have an edge over traditional static analysis tools, because they can actually read code the way a human would. How did Google know AI wrote it? The code gave itself away. The Python script was full of educational doc strings, detailed comments explaining what each function does, formatted like something out of a university course on secure coding. It also cited a CVSS severity score for the vulnerability. CVSS is the industry standard system for rating how dangerous a flaw is, and the score in this script didn't correspond to any real entry. The AI had hallucinated it and formatted it convincingly. The overall structure was what the report calls textbook Pythonic. GTIG is confident it wasn't Gemini. They haven't said which model it was. The group behind it has, in Google's words, a strong record of high-profile incidents and mass exploitation. Their plan was to deploy this exploit widely and fast, because they need to hit as many systems as possible before a patch closes the window. Google disclosed the flaw to the vendor, the patch got issued, and the campaign was disrupted. This is just one incident in a much larger report. A China-linked group called UNC 2814 went a different direction. They jailbroke Gemini using expert persona prompts, instructing it to behave as a senior C++ binary security expert to probe TP-Link router firmware for pre-authentication remote code execution flaws. Russia's contribution to all of this is genuinely strange. GTIG identified two malware families, Canfail and Longstream, where the source code is padded with large volumes of AI-generated inert code, included purely to make the malicious logic harder to find. What makes this notable is that Canfail's own source code contains developer comments written by the LLM, explicitly describing certain blocks as unused filler content. There's a defense side to this too. Google's Big Sleep AI agent found a zero-day in SQLite through automated code analysis before it could be exploited. And separately, Anthropic just released Claude Mythos to a small set of companies through a program called Project Glasswing. The problem is that defensive AI is reactive by design. You're patching software that already exists in already deployed systems. The attacker only needs to find the one thing the defenders missed, and now they have a tool that can read code at a scale and consistency that no individual security researcher can. Hultquist put it plainly, there's a misconception that the AI vulnerability race is imminent. The reality is that it's already begun. Thanks for watching, and I'll see you in the next one.